Topic: Irrigation and water supply. At the end of this lesson you should be able to understand the following concepts: overhead irrigation systems, center pivot irrigation, movable sprinklers, wheel line irrigation, portable sprinkler irrigation system. Introduction. Learning content that was dealt with in grade 10, 11 and term 1 grade 12 must link in with the current content that will now be dealt with. Grade 10 Irrigation and water supply. Grade 11 Irrigation and water supply. The purpose of this lesson is to cover content associated with the various macro irrigation systems. Concepts and skills. Irrigation and water supply. Reasons for irrigation in SA. Optimal plant production can only take place if there is sufficient water available. Large parts of SA are subject to hot and dry climatic conditions, high evaporation and low and erratic rainfall. Irrigation is needed to replace or supplement rainfall. Irrigation problems. Competition for surface water rights. Use of underground water resources. Ground subsidence. Too little water supply or irrigation that provides just enough water to the plant, e.g. drip line irrigation, causes brackish soil which leads to the accumulation of toxic salts on the soil surface in areas with high evaporation. This necessitates rinsing or drainage to get rid of the salts. Over-irrigation due to poor distribution or management can waste water and chemicals and cause water pollution. Deep drainage, due to too much irrigation, can cause the water table to rise and in some cases lead to brackishness. Irrigation with brackish water or water with a high salt content can damage the soil structures. Basic procedure to follow when selecting a pump for a new irrigation system. Decide on a type of pump that will work best for your needs. Rotary screw pump, centrifugal pump, submersible pump, turbine pump, jet pump, etc. Determine your flow, LPM and pressure needs. Look at the models of the available pumps and choose a preliminary pump that will meet your needs. Design a preliminary irrigation design. It must be designed for the flow and pressure that the pump must deliver. If you have a preliminary design, it will be easier to choose a suitable pump. Will another pump lower your irrigation cost or better match your irrigation design? Go back to the pump selection process and reevaluate it. Make your final choice. Go back to your design again. Could it possibly be changed to meet your final choice? Make the necessary changes. Aspect information. Layout plan, layout of the blocks and detailed plans of each block. 2 copies should be provided, 1 for installation purposes and 1 for records. Cost estimate, price estimate of the total project and each phase of the project if applicable. Quantity list of items needed per block. Detailed sketches of equipment to facilitate installation. Tap connections, drawings of the taps with the required fittings. Filter banks, drawings of the complete filter setup with manifolds and taps. Pumps, drawings of the pump with the required equipment. Pump curve, a pump curve indicating the service point for use so that the pump's efficiency and the power required can be easily read. The pump curve is also needed if the existing irrigation system is to be expanded in the future. Final technical report, a report that describes the resources that are part of irrigation development and briefly describes the operation of the system. Maintenance and management manual. A complete manual on how to manage and maintain the irrigation system is necessary to ensure that the performance of the installed irrigation system is always optimum. SOBI design form, technical design specifications to which the design complies. Other important information needed. 1. Level of expertise of designer. The level of expertise of the designer, for example, is a certified SOBI designer or a professionally registered engineer or technician. 2. General system information. The expected life of the system. Safety factors built into the system. Expansion possibilities of the system. Additional equipment that should be available on the farm to replace faulty equipment. 3. Description of the proposed irrigation system. Groundwater properties of the soil being irrigated. Type of irrigation system used for irrigating the different crops. Type of radiator proposed and what is the recommended working pressure, spacing and delivery of the radiator. The capacity and quality of the water source available for development. The suitability of the water for irrigation of the specific crop. Four, design parameters. Design parameters used. The flow rate of the water in the main line. The recommended working pressure at the tapping points. The design distribution coefficients. The gross application rate of the system compared to the infiltration rate of the soil. 5. Scheduling planning. The readily available water in the effective root area. The gross irrigation needs of the different crops being irrigated. Blocks to be irrigated together. System cycle length and stand/revolution time. The system capacity in mm/day and how it compares with the information obtained from a crop expert. 6. Equipment. A pump curve on which the service point is indicated. The pumping time within the Eskom peak rate time. The energy cost per hectare per year. Filtering required, if any, and what type was provided. Injection pumps provided, if any, and their capacity. The provision of a flow meter and the requirements with regard to installation. Provision of adequate air inlet and air outlet valves in the system. The status of water battle. 7. Guarantees. Guarantees of the individual components of the system and what it includes and excludes. Guarantee that the system will function according to the design parameters. Availability of the proposed irrigation equipment when faulty equipment needs to be replaced. Who and how will be determined whether the system meets the design specifications, in other words, how will it be tested. Equipment that should be kept as emergency supplies. A written undertaking confirming that the system complies with the ARC ILI and SOBI norms and if not, where deviations occur. Overhead irrigation. Water is pumped under pressure and spreads to the plant from a flat sprinkler. This can be connected to an overhead aluminum pipe network or can simply be connected at the top. Since it is difficult to distribute water evenly, a more expensive overhead system is better. This system, which moves across the length of the land, can more easily control water distribution. Another overhead irrigation system is the cannon irrigation system, which, as its name suggests, shoots water into the air and over land. A large water cannon sprayer can cover a large area or land without being moved. Overhead irrigation systems are useful when watering large areas. Some can be disconnected and moved to another country without effort. Circular Irrigation Center Pivot https://u2.be/levwk_voc https://u2.be/2billpvh3euq https://u2.be/oivjuq0noc0 Rotation type pivot irrigation nozzle. First hub was designed and built in the USA in 1949. First commercial hub was available in 1953. Pivot irrigation is a form of sprinkler irrigation consisting of pipe segments, usually galvanized steel or aluminum, that are coupled and supported by struts, mounted on wheel towers with lengthwise spreaders. This system moves around and gets water from the irrigation point in the middle. These systems are used where the terrain is flat. Newer irrigation systems have pipes that hang as seen in the photo that follows. Gearbox of a pivot point https://u2.be/dfhkbrqn6fu https://u2.be/wr6kw phase sy. How is a pivot point made? https://u2.be/nd4zdnud5i4. Adjustable irrigation sprinkler head. Basic principles and operation. Most of the pivot irrigation systems have spreaders that overhang a U-shaped pipe called a gooseneck. It is connected from the top of the pipe with spray heads a few feet, maximum, above the plants. This limits evaporation loss. Water supply takes place from boreholes or dams by means of pumps. Water is pumped in at the pivot point, after which it is fed through the length of the pipe. Sprinklers are mounted at the bottom of the supply pipe that do the irrigation. The towers on which the pipes rest are fitted with hydraulically driven wheels. The towers on which the pipes rest are provided with wheels that are driven by electric motor. The system moves slowly in one direction around the pivot point according to a scheduled program from the control panel installed at the pivot point. Most modern systems use GPS technology and the system is largely automated. Center pivot irrigation system. What is a center pivot? A center pivot is a mechanized sprinkler system that irrigates crops in a circular pattern around a pivot point. A span of pipe is supported on an A-frame with wheels and the pipe transports water to attached sprinklers. Pivots are capable of applying water, fertilizer, chemicals, and herbicides over large areas of land to increase yields, while saving time and cost. Different parts of the center pivot. 1. Pivot point. The pivot point anchors the machine to a permanent location in the field. Not only is it an anchor, but it also houses a system of subcomponents that contribute to the overall functionality of the pivot. These important subcomponents are the pivot legs, riser pipe, pivot swivel, control panel, J-pipe, and collector rings. A. Pivot legs. The pivot legs hold up the pivot point and give the machine its structure. The 4 pivot legs are typically bolted to a concrete pivot pad, providing support. B. Riser pipe. The riser pipe is connected to the first span through the pivot swivel. The purpose of the riser pipe is to supply water to the rest of the center pivot irrigation machine. C. Pivot swivel. The pivot swivel is an elbow-shaped fitting that connects the riser pipe to the first span. D. Control panel. The control panel is mounted and accessed at the pivot point. The control panel gives the machine commands to start, stop, move in reverse, pump water, and many other functions. More on this component later. E. J-pipe. The J-pipe houses the power and control circuit wires. These wires move through the J-pipe to the collector ring assembly. F. Collector ring. The collector ring assembly is made up of stationary brass rings with contact brushes that rotate around them. This assembly makes it possible for a continuous flow of electricity to run through the machine as it rotates around the pivot point. 2. Control panel. The control panel is the brains of the operation. It allows the operator to control the entire machine by sending commands to tower boxes mounted on each drive unit. The control panel controls the stopping, starting, forward and reverse movements of the pivot, water usage, and much more. 3. Spans. Spans are the backbone of the whole center pivot structure. Spans consist of pipes that transfer water to the field via the pivot sprinkler package. The span pipes are supported by trussing in the drive units. 4. Drive units. The drive units and the supporting structure are also known as towers. They provide clearance above the crop for the spans and control the movement of the machine. Each drive unit consists of a drive motor, gearboxes, wheels, and an electrical control box known as a tower box. 5. Tower boxes. Each drive unit has a tower box that uses various components to control pivot movement and alignment. Span cables carry 120 and 480 volts of alternating current, VAC, to each tower box. Tower boxes then send 480 VAC to the drive motors when signaled to move by the 120 VAC control circuit. Advantages of the center pivot point. Little labor required. Low maintenance. Very convenient. Easily adaptable to changes. Very effective. Bring water savings. Save a lot of energy and time. Important aspects to consider when purchasing a center pivot point. The diameter of the supply pipe. The length and number of towers required. The drive system. The adequate water supply at the pivot point. The method of sprinkling. Sprinkle irrigation https://youtube.be/txkb_gp7mty. In sprinkler and overhead irrigation, water is distributed in pipes from one or more central locations in the country to overhead high-pressure sprayers or cannons. A system that has overhead sprinklers, or cannon heads is called fixed-set irrigation. Creep irrigation https://u2.be/0dw5-4bsg0 https://u2.be/rwxcxuset-y. Sprayers can also be connected to moving platforms connected to a water source with a pipe. Automatic wheel systems known as crawler sprayers can be used on small farms, sports fields, parks, and unsupervised cemeteries. Most use a length PVC pipe on a steel drum. As the pipe turns around the drum by the pressure of the water or a small engine, the irrigation system moves across the land. Once the irrigation system is back at the starting point, turn it off. This is known as a crawler sprayer. Lateral move irrigation. Lateral movement, side roll, wheel line irrigation. Pipes, each with a wheel about 1.5 m in diameter, permanently connected to the center with spreaders over the length, are connected to each other on the side of the land. Water is connected to one side by means of a large pipe. After sufficient water has been applied, the pipe is removed and the system moves 10 m further by hand or with a built-in mechanism. The pipe is reconnected. The process is repeated until the other side of the country is reached. The system is cheaper to install than a pivot point, but is labor intensive and the amount of water is limited to what the system can carry. Most systems use 4 or 5 inch, 130 mm diameter aluminum pipes. One feature of a side roller set is that it consists of easily disengaged sections. It is used for small lands or lands with an unusual shape, as found in hilly or mountainous parts, or parts where labor is cheap. Irrigation software https://u2.be/w0bybwadf0 https://u2.be/wal-fobs9m. What is irrigation software? Smart irrigation software allows farmers who are involved in irrigation activities to optimize water usage. The software is able to regulate water levels depending on various factors such as weather predictions and soil moisture levels. Controls, zones and valves https://u2.be/iczdqwg6crc https://u2.be/pf9wtnco4hk. Most irrigation systems are divided into zones. A zone is a single irrigation valve and one or more sprayers connected by pipes. Irrigation systems are divided into zones because there is usually not enough pressure and flow available to use the spreaders for an entire yard or sports field. Each zone has a solenoid valve that is controlled by the irrigation control mechanism. The irrigation regulator is either a mechanical or an electrical device that sends a signal to a zone to turn on at a certain time and stay on for a certain time. A smart control system is a system that can make water adjustments itself as conditions change. It uses data from previous weather conditions in the local area, soil sample sensors, water potential and water content, rain sensor, or in more sophisticated systems satellites that send information to weather stations, or a combination of these. Irrigation valve. https://u2.be/5rockxhhxorsw https://u2.be/6yards@hwvnm. An irrigation valve regulates the direction in which water flows in an irrigation system. These valves are found in the irrigation systems of crop production, parks, golf courses, and lawns. They help control water in above ground as well as underground systems. Irrigation flow meters https://u2.be/zqdo81ykjk. What is an irrigation flow meter? A flow meter accurately measures the amount of water volume applied. An accurate flow meter is an essential tool to practicing good irrigation scheduling. The two most common types of flow meters for irrigation are electromagnetic and propeller. What is an irrigation flow meter? A flow meter accurately measures the amount of water volume applied. An accurate flow meter is an essential tool to Practicing good irrigation scheduling. The two most common types of flow meters for irrigation are electromagnetic and propeller. Irrigation sprinkler. A sprinkler applies water to a land with the effect of rain. Most sprinkler irrigation systems use pipes with water under pressure, which then escapes through the nozzle heads and is dropped on the ground. The basic goal is to let water through, but the types may differ. People considering a spreader should consider how large the area to be irrigated is as well as what the shape of the land is. Obstructions such as trees and rocks will require extra work to wet them. How deeply the soil must be wetted, as well as the time and labor required for the system must be taken into account. A spreader is a spreading device that is connected to the tip of a water pipe. The head is the device through which the water is distributed. There are different types of spray heads available. It depends on where the sprayer is going to be used, with a special design for overhead sprayer heads. The nozzle head is quite small and is connected to a nozzle connector with a central ring for the flow of water. The top of the sprayer is arranged round with fins or thin blades in the round. When the nozzle is activated, the water flows through the nozzle head where it changes from a stream to a circular pattern. The water application is designed to maximize the irrigation area. There are two common types of sprinkler heads, lawn and firefighting systems. In both cases, the requirements are the same: the water must be distributed without any human assistance. Through good planning and design, it is possible to wet the entire area. Lawn spray heads can be sunk into the ground and shot up again by the pressure of the water when the system is activated, and can also be fixed above the ground. In a lawn spray system, there are two types of heads. A nozzle head is designed to deliver a large amount of water in a short period of time. https://youtube.be/hgcyvzllbc. A rotating sprinkler head sprays water at a slower speed and covers a larger area over a longer period of time. Used in large areas that need regular watering due to soil and climatic conditions. A sprinkling head is designed with a moving arm that forces the water to follow a circular motion. The fire extinguisher, https://youtube.be/o-ylvagYC0w. The fire extinguisher is the spreader head that is attached to the ceiling, with the top of the head facing off. Inside the sprayer is a heat-sensitive mechanism or a two-piece metal connector held together by an alloy. The heat-sensitive mechanism or metal lies transversely to the top of the head and functions as a plug to keep the opening closed. Activities/assessment. Activities. When will sprinkler irrigation be preferred over flood irrigation? When water supply is poor. When the surface gradient can lead to erosion. Infiltration rate not constant. Drainage problems. Not high cost of leveling land. Sprinkler irrigation consists of 6 primary parts. List these primary parts. Engine/electric motor. Pump. Pipes. Sprayers. Control box. Water flow meter. Name 2 drugs that should never be administered through a pivot point. Give reason for each. Insecticides or fertilizers with a high acid content will cause the pipes to wear out. Fertilizer with large particles will clog the opener's openings. Name an electronic method for the farmer to communicate with the pivot point so that it can be activated or stopped over long distances. Mobile cell phone. Briefly describe the precautionary measures that must be in place to prevent the pivot point from falling. When one of the wheels gets stuck or the electric motor that controls the wheel breaks. When the system goes out of line, a safety switch must cut off the electricity to the wheels to prevent it runs forward. The spreaders in the system can be easily blocked with debris or rust in the pipes. How can this? Waste material is removed in the pipes without disconnecting the whole system. The tap on the tip of the system must be open so that all pieces of impurities can flush out of it. The tap must be closed again so that the system can function again. Sprayers form part of the irrigation system. What is the function of a sprayer head? Distribute water evenly over large areas. Name 2 effective materials used to make the spray heads as in the picture and name 1 advantage of each material used. Metal, copper, galvanized iron. Galvanized metal were not so easy. Plastic cannot rust. Learners can use previous year's NOV Grade 12 papers to study sample questions.
Please like, share, and subscribe to the channel for more future educational videos.